Hello and welcome again. In the last few lectures, we have been discussing about diet formation evaluation method such as mud logging and coring and core analysis. Like in mud logging, we have been analyzing the drill cutting and returning mud to the surface for the presence of oil or gas and get an idea about the lithology and rock type and the mineralogy of the formation and also porosity and permeability indication about the reservoir. Where in the coring and core analysis, we were taking a formation related rock sample from the well bore and analyzing it in the laboratory for porosity, permeability, and various other measurements. Today, we'll start discussion on wireline logging operations, where we are going to lower a number of tools inside the well bore to take a number of measurements, and these measurements could be interpreted in terms of formation properties, which could be saturation, which could be porosity, which could be lithology, and others. So let's start today's lecture. So today I'll introduce you to the wireline logging. I will discuss what are different types of logging tools are there, and we will have discussion on the borehole environment, which could have bearing on the wireline logging tool data recorded or the measurements. So we must know what is the borehole environment and also know the borehole environment properties such as mud and filtrate properties, which would help us in the interpretation of our wireline logging data. Typically, the wireline logging can be classified in three types. One is the open hole logging, second is the cage hole logging, and third is the production logging. In open hole logging, we are going to take the data to characterize the formation in open hole condition. That means the well has not been cased yet. That means the records are taken just after the drilling operation. Where in caged hole logging, the records are taken when the casing has been set. Few other tools could be similar. It could be same. The tools which are used in open hole logging, such as gamma log, can also be used in caged hole logging as well. But objective of the caged hole logging and open hole logging is different. For open hole logging, our main objective is to evaluate the formation, to characterize the formation, calculate the formation properties. In the cage logging, our objective may be to evaluate any ongoing field operations or the evaluation of, let's say, water injection program, which is done by them measuring the change in the formation rock and fluid properties. And lastly, in the production logging, the objective is to help in the production of the well. So if there is a problem during the production, well is not producing. So if we need to find out what type of problem is there in the well, then we need to carry out the production logging tool. We need to load the production logging tool in the well bore and find out what is the cause of problem in the production. For example, let's say the well has, let's say, 3 layers. So which layers are producing, which layers are not producing, and what are the individual production rate from each well bore. So those type of things are characterized. So a complete information about the production well, which included from the type of fluid being produced, its properties such as density, viscosities, and at what rate it is being produced, and at depth or from which zones these fluids are being produced, are evaluated in the production logging. So coming back to the open hole logging, as I mentioned, it is done just after drilling a well bore and before the well is cased. So objective of open hole logging is that to measure the different parameters or the properties which can help us in the drilling of the well bore. For example, knowing the rock type and the pressure and temperature, it could help us decide the mud type and also the mud weight. And based on the knowledge of the formation, we can decide what type of completion equipment need to be chosen. Let's say, for example, how many wells how many zones are there. So whether you go for a single string completion or dual string completion, whether we need to isolate the different zones using packer, or the fluid could be produced together from different zones. So those type of things could be optimized by knowing the data about the formation. It will help us. And the estimation of hydrocarbon reserves and estimation of well productivity, that is the fundamental objective of formation evaluation. So open hole log will tell us the idea about the different rock and fluid properties such as porosity, saturation, permeability, thickness, boundaries, which can help us quantify the hydrocarbon reserves as well as define the well and reservoir productivity. So all this information will help us create a development plan for the extraction of hydrocarbon resources from the oil and gas reservoir. So the plan could include how many wells to be drilled, what should be location of the well bore, what should be the acreages or the spacing between the well bore, and the in what rate a reservoir well should be produced. So those things of optimization can only be done once we have gathered the information about the reservoir through different logging measurements. These are the few common logging tools which are generally run in the wellbore, such as gamma ray log, resistivity, neutron, and bulk density log. Although not mentioned here, but caliper logging tool is also run on almost all the wellbore. So these are the logging tool lists, we can say, which we are going to have a discussion in this course. Although there are a number of other logging tools are also there, such as EPT log or NMR log, but we are not going to discuss those tools. These are fundamental logging tools which we find will be found in the most of the wells when the records are taken. Starting from the caliper log, which is going to measure the borehole diameter. Many times caving might happen, there may sudden borehole enlargement may happen. So the assumption that the borehole size will be same as the bit size is not true. So usually you might think that we are drilling a well, let's say 9-inch bit, for example, let's say 9-inch bit, and so you think that the borehole size will be 9-inch, but it will not be 9-inch. It may be larger than 9-inch because, for example, if you're drilling through a, let's say, shell reservoir, so water might come in contact with the clay present inside the shell, and it might cause the clay swelling, which might cause the layers of the shell to follow the formation wall and cause a change in the wellbore diameter. So those changes could be identified if you run a caliper log to measure the wellbore diameter. Other logging tools such as electrical logging tools, which are designed to measure the resistivity of the formation. So we will discuss induction log, lateral log, and micro log, which will measure the resistivity of the formation or the conductivity of the formation. So resistivity of the formation will be used to calculate the saturation of the fluids inside the formation. Then we also discuss SP logging tool. The FP logging tool which measure the naturally occurring potential inside the wellbore, which could also help us in identifying saline formation and non-saline formation. Then we discuss three types of nuclear logging tool, which will density, neutron, and gamma ray log. Gamma ray log, it records natural gamma ray coming from the formation to delineate between saline and non-saline formation. But the density and neutron logging tool, where we send artificial radiation inside the formation and then take the reading of how this artificial radiation, such as either gamma ray or neutron, which have been injected in the formation, how they interact with the formation to calculate basically the property of the formation and give us an idea about lithology. We'll also discuss sonic logging tool, which where we send this sound wave inside the formation and measure the travel time of the sound wave inside the formation to get an idea about porosity and well the lithology. So this figure, just continuation of the earlier figure that we just discussed. For example, electrical logging tool, they primarily measure the resistivity of the formation. And if you see here, bronze, like lithology here pore geometry, permeability, fluid properties, structure. These are circles that represent, like resistivity measurement will be affected by the lithology, pore geometry, permeability, fluid property, and other. But they are only designed to measure the resistivity of the formation, which is later converted to saturation values. Same as you can see, let's say gamma density logging tool. Density logging tool and neutron logging tool. They two are primarily designed for measuring the porosity of the formation, but they might be affected by the geological structure and other parameters such as lithology, mineralogy, and geomechanical properties. So green color depends that on the density and gamma ray logging tool, like density and the neutron porosity logging tool, they are designed to measure the porosity, but they are influenced by lithology, and with the help of other log or by studying 2 or 3 log together, we can density log data and neutron logging data can also be used to calculate the lithology or mineralogy of the formation. The blue circle is the primary measurement. Green circle is the measurement that with the help of this logging tool, which we can measure by combining with other log data. And the brown color is nothing but represents that these logging tools are affected by all these parameters, but the tools are not designed to measure those things, but the tool data will be affected by that. So how do we take a wireline log or open log data? For example, in this figure, if you see at the surface, we have a logging truck, and the job of this logging truck is to send this logging tool inside the wellbore. For example, this is a example of ratio logging tool. You can see where we have electrodes here, which is basically designed to send a current inside the formation to measure the ratio of the formation. So let's say we want to measure the ratio at formation here. So tool must be here. So job of this logging truck is to lower this wireline logging tool by keeping a record of what is the current location of the tool, and also provide telemetry so that the data could be transferred to the surface. So every wireline logging tool is carried out by lowering the tool on a wireline. So the wireline, there will be wireline here from the tool, and this wireline you can see it will be used to lower the tool inside the wellbore at respective depth. Then the record could be taken at different depths. For example, this is a gamma ray record. So we have taken the gamma ray record at different depths. This might be a Selly formation because it has high gamma ray log reading, and this might be a porous formation because it has low gamma ray reading. So typically, if you see, this is how a logging truck looks like. You can see the wire line is coming out from here. You could have acquisition and processing computer at the well site itself. Here you can record the data at the bottom of the wellbore, and the data could be transmitted to surface through telemetry. And preliminary analysis of well log could be done. The logging engineer at the well site could look at the log data, such as the HTT and the gamma ray, and can comment on the type of formation being drilled, which can also help the driller to plan the drilling activity ahead. So typically what we have a logging truck or surface logging will have logging cable. So logging cable which or along with winch which will be used to raise or lower the cable inside the wellbore. Then different logging tools. So if you want to, let's say you have planned to run the gamma logging tool, density log and nitro logging tools, so those logging tool must be there at the well site to lower inside the wellbore. So logging tools will be transported from the warehouse to the well site along with our logging unit, surface logging unit, and there will be assembled and then we'll send inside the download condition. A power supply, surface control equipment, data recording unit, data display requirement, and data transmission equipment if you want to transmit also. How this logging surface logging truck works, how we operate the winch, how the winch control works, how do we load the tool, the operational part of the while logging operations, which involve basically preparing the tool at the well site, attaching tool to the wireline logging unit, and then lowering on through the wellbore. This part will be not part of this course. The operational part, we will only discussing the data acquisition and interpretation part. Now, the next part of today's lecture is the borehole environment. We need to study the borehole environment in which logging tools are run to take record of the borehole condition which is needed to interpret our wireline logging tool data. For example, let's say this is the initial formation condition. The initial formation condition could be, for example, if you have a water reservoir where the water saturation is 1, or let's say if you have hydrocarbon reservoir such as oil and gas where you have initial oil and gas saturation and coolant water saturation. When you start the drill, because the logging tool will be run when the drilling has been done. So you have started drilling. So during drilling, what happens? The fluid invades. In the fluid invade, what happens? The mud filtrate goes inside the formation. When the mud filtrate goes inside the formation, what will do? It will displace the formation fluid. So formation water on oil will be displaced. So our wellbore and formation condition will be altered. So what is the current condition in which logging record have been taken? We must understand before interpreting the wireline logging data. So a typical borehole condition will look like this. In the wellbore, you will have mud. At the formation wall, we have what? Mud cake. Inside the formation, we'll have altered fluid saturation. Initial fluid saturation will be the corresponding to water and hydrocarbon reservoir, but new altered condition will be what? Where along with the formation fluid, what we also have mud filtrate present. Okay, so for example, if you want to measure saturation of the fluid, okay, you need to keep in mind that at what depth inside the formation you are measuring the saturation, so that we measure the true saturation of the formation fluid, not the mud filtrate saturation. So these things will focus in today's and also in the next lecture also. So for example, typically the different these are parameters that we need to consider before interpreting any logging tool data. So what type of mud is there inside the wellbore? Oil-based mud or a water-based mud? What its properties, its densities, and everything, its resistivity. So mud and mud filtrate properties. So either we can measure in situ condition if possible, or we can take a mud and mud filtered sample at the surface and measure the property of the surface and then transform those properties to the reservoir pressure and temperature condition. Saturation history of the formation. So what are the initial saturation of the formation fluids and what is the saturation of formation fluid after the invasion must be needed. For example, when you're trying to calculate the porosity from density log, we need to know that what is the current saturation level in the formation. Invasion diameter, the diameter up to which say the mud filtered has invaded, and along with the pressure temperature condition and the depth condition to calculate the temperature. So we'll discuss a few of the parameters, how it happens and what type of changes it can cause in our wireline log operations one by one. First thing is that we need to calculate the temperature. Temperature is necessary because a number of properties need to be calculated the formation temperature. For example, mud properties and mud filtered properties such as resistivity and viscosity might be needed. So typically resistivity have to be, if you are using mud filtered resistivity or mud resistivity in any of the petrophysical calculations, it must be at the present temperature condition of the depth at which we are trying to do the calculations. So for that we need to know the formation temperature. So formation temperature will be nothing but what is surface temperature plus what is the temperature gradient, that is how the temperature is changing with respect to depth, multiplied by our true vertical depth. So by knowing the temperature gradient or geothermal gradient and the surface temperature, we can calculate what is the formation temperature. Or you can also use a cross plot. It's not a cross plot, it's a curve from Schlumberger where you can see depending upon the surface temperature, you can pick a surface temperature and you can pick your geothermal gradient and calculate the temperature. So accordingly, you can pick the chart with the surface temperature here, pick the appropriate the temperature gradient curve from any of them and just go at the depth to calculate the temperature. So this way this chart could be used. I will be introducing a number of chart and cross plots throughout the well logging, and mostly I will be giving you example of Schlumberger chart, some of the chart books, because the information about them is available in the public database. What I will suggest you to that you can go on Schlumberger website and you can make an account and go to the website. There will be a section where you can download two things. One is they offer a free book on open hole logging, its principle and application, and then Schlumberger chart book. Since I cannot say that because I don't have the sharing rights, but you can make an account and for your personal use, you can download those two books. Now, you know that the mud filtered invasion happens. So mud filtered goes inside the formation, and we also know the mud cake also forms in the wellbore. So typically, we need the mud resistivity and the mud cake resistivity or the mud filtered resistivity in resistivity log data interpretation. So in resistivity log data interpretation, where we are trying basically whatever the resistivity logging tool measures, we call it what? Apparent formation resistivity. Okay, and RT data must be converted to true formation resistivity. That is a true resistivity of the formation. In order to calculate that, we might need RMC, RM, and RMF. So a way of measurement of RMC, RM, and RMF is that you do filtration studies at the surface in the laboratory, prepare a mud cake sample, prepare a mud filtered sample, and mud sample and measure its resistivity, and then use the different correlations to calculate the resistivity to at the resistivity at the pressure and temperature condition of the formation. Typically, we can use this correlation RMC, which is generally as 1. RMC mud cake ratio taken as 1.5 RM, and mud filter ratio can also taken as 0.75 RM. These are some statistical approximation is there for NaCl based mud, or you can use a number of other correlations given by different people such as Slow and Dunlap correlation, which relates the mud filter resistivity to its density of the mud. Only if Rm is in the range of 0.1 to 2 meter at 75 degree Fahrenheit. In that conditions, you can use this equation. You can use Overton and Lipson correlation also, which relates the mud resistivity and mud filter resistivity like this, and mud cake and mud filter resistivity like this, where Km is given depending upon the density of the mud. Okay, it can be calculated as according to the following table. Once again, it works when the Rm is in the 0.1 to 10 and temperature is around 25 degree 5 Fahrenheit. So these are the few correlations are there. So depending upon the mud type, you might choose a correlation which might be suitable for your calculations. Now let's discuss the mud filtered image in a little bit detail. So and discuss the few terminology associated with our mud filtered invasion inside the formation. So first, why mud filtered invasion happens? Because we know that we try to keep the well pressure greater than the formation pressure. Because if the well pressure is, or the pressure at the bottom of the well bore, or some PWF, we can say, since it is not a flowing well, so I'm just writing the PW also. Otherwise, the bottom hole pressure is normally denoted as PWF in the production well. So, pressure at the bottom of the well bore must be greater than the formation pressure, because if the pressure of the well bore is less than the formation pressure, what will happen? The formation fluid will come inside the well bore and cause kick or blowout. So we don't want the formation fluid to come inside the well bore. That's why we always maintain the well bore pressure at the bottom of the well bore at least 200 psi greater than the formation pressure. So this way what happens that we are getting a pressure difference inside the formation. So obviously the mud will try to go inside. But solids in the mud, they start to, which cannot go inside the formation, they start to form a mud cake at the formation wall. So solid of the muds, they get deposited on the walls of the formation and they form a layer which is called mud cake, which have very less permeability. So it prevents the further fluid transfer inside the well bore. But during the formation of this mud cake, until the mud cake is formed, some part of the mud will go inside. So let's say what the liquid has been filtered out, along with some solid might go inside the formation. That liquid part is called what? Mud filtrate. So in the borehole condition, what will have inside the well will have mud. At the formation wall we have what? Mud cake, and inside the formation what is going? Mud filtrate is going inside the formation. So here we have mud, here we have mud cake. Now, initial condition of the formation was what we had with everywhere we had what? True formation or undisturbed formation. Now, two different zones are created. One is called the flush zone, second is called transition zone, or in few books you will also see it called the invaded zone. Typically, this is the, we can say that this is the whole invaded zone. It is better to call this second zone as transition zone. And the flush and transition zone should be called as invaded zone. The flush zone is a zone where the flushing is complete. Flushing is complete in the flush zone. What do we mean by the flushing is complete? So mud filtrate, when it is going inside the formation, it will displace the formation fluid. If it is going, it must displace whatever it was there earlier when the flushing is complete. So that means mud filtrate cannot displace any more of the formation fluid. So the two things can happen either in the mud filtrate in the flush zone. Two things can happen: either the mud filtrate can displace all of the formation fluid and occupies solely all the space in the flush zone, or it can displace the formation fluid to its irreducible level, and mud filtrate and the formation fluid will exist at irreducible saturation. Then there will be a transition zone where the flushing is incomplete. That means mud filtrate has invaded, but it was not able to displace all the initial formation fluid. So as you move further, what will happen? Amount of mud filtrate will decrease. So if we move away from the flush zone towards the undisturbed zone, amount of mud filtrate will decrease in the transition zone. Then in the undisturbed zone, what will happen? We'll have true saturations. That means initial formation fluid saturation. So today we discussed about different types of wireline logging tool operations, and in open hole logging, what type of data do we record by loading which type of logging tools. At the end, we started discussion on mud filtered invasion. We discussed what type of zones such as flush, transition, and invaded zones are created. In the next lecture, we will have discussion about the formation properties in all these zones. That means how the formation rock and fluid properties can vary in flush zone, transition zone, and uninvaded zone. See you in the next lecture.